Google Cloud Workflows is a service to help you more easily connect and chain together other services, including Google Cloud services, your own custom services, and external third-party services into solutions. And now, thanks to Parallel Steps, you can speed up your workflow executions. But first, how can workflows help you? You can create complex workflows like advanced data processing jobs, multi-step service orchestration, or automated cloud resource provisioning with ease. Workflows also make it easy to connect other Google Cloud services with a library of connectors that handle authentication and formatting of requests for you. So you can focus on what's important, running your jobs on a scalable serverless backend. Thanks to all this, Workflows is an ideal solution for gluing together services like BigQuery and Cloud Run to build processing pipelines for data, media, or machine learning jobs. Or you could automate common platform operations processes and have them trigger based on a schedule, manual action, or from an event. Each step of a workflow is executed sequentially, so you can build full, reliable applications or build modular jobs and integrate them into larger systems. But what happens when your workflow has steps that might take a while to execute, like multiple long-running queries? Normally, each step will wait for the previous one to complete, even if the current step doesn't depend on the previous step. When running multiple independent queries, you probably don't want each query to block execution. Thanks to the new Parallel Steps feature, you can speed things up and run steps at the same time. You can build your workflows and define which steps are parallel, so those steps can be run without blocking execution. Using parallel steps can help to decrease the overall time it takes to run your workflows. Let's show you exactly how parallel steps can help you speed up the execution of multiple long-running operations by walking through a sample. We'll start with a workflow that executes multiple queries on Wikipedia data and see how long that takes. Then, we'll update the workflows to use parallel steps and see the difference. In this example, our workflow will query 5 different Wikipedia tables to find the most popular pages. We can use BigQuery sample datasets to access the information from Wikipedia. Each table in a dataset represents a different month, and we can run a simple BigQuery job on each table to find the most popular pages from that month. We'll start with a workflow that executes the steps sequentially. Here's the code from Workflows that shows how the tables are queried. First, we'll declare the tables that we want to query against the init step, as well as the results variable that will hold the results from the queries. In the run query step, we'll loop over the tables and query each one for the pages with the most views. Each query takes about 20 seconds to complete. After the query is run, we'll grab the top results from each table and add it to the results variable. Check out the link in the description to a code lab that has access to the full code so you can try it out for yourself. Running this workflow gives us data we were looking for. Looks like each month had the same top page, with page views in the millions. But because each query was run sequentially, it took around 100 seconds, since each query had to wait for the previous query to complete before starting. The whole workflow takes as long to run as each query combined. Now, let's convert this same workflow to use parallel steps and see how long it takes. Adding parallel steps couldn't be easier. In fact, we just need to place the for loop inside a parallel step. In addition, we'll declare the results variable as a shared variable so each query can store the results in the shared variable. Creating a shared variable ensures all assignments are atomic, so you don't need to worry about race conditions or which order the jobs are executed in. All you need to do is declare a variable as shared, and Workflows will handle the rest. Now, when we run our workflow with parallel steps, we get our results in the same time it takes to run a single step, 20 seconds. Running steps in parallel can speed up any workflows that have long-running steps which needlessly block other steps from executing, or when you have multiple branches that can be run in isolation. To try parallel steps in Cloud Workflows out for yourself, check out the code lab in the description. You can also learn more by visiting the documentation. Happy workflowing!